professeur James Pinfold, le 5e lauréat Killam de 2018, ne pouvait malheureusement pas être ici pour cet événement. Cependant, il nous a surpris. Il a décidé de faire quelque chose de remarquable et de réaliser un petit film. Donc, ça va faire content Louise Poissante. Un petit film qui exprime ses réflexions sur le rythme. Il a tellement aimé l'expérience qu'il a l'intention de faire une deuxième partie pour un événement futur, peut-être en collaboration avec notre laboratoire de recherche. Et donc, c'est un petit film de 7 minutes et afin d'avoir une période de discussion avec lui, j'ai décidé d'interviewer professeur Pinfold cette semaine via Skype. Et nous avons fait un petit montage de ses réponses qui vont montrer à la suite de son film. Alors, pour introduire James Pinfold, il est un physicien de particules de renommée mondiale qui, en 1997, est devenu le plus jeune chercheur à diriger une expérience internationale sur un collisionneur. En 1972, alors étudiant diplômé à l'Université College de London, M. Pinfold a joué un rôle de premier plan dans la découverte du courant neutre au CERN, la première preuve tangible de l'unification électrofaible. En 1972, il est devenu membre fondateur de l'expérience ATLAS, au grand collisionneur de hadrons du CERN qui, en 2012, annonçait la découverte du boson de Higgs. Professeur émérite de l'Université d'Alberta, il est actuellement le porte-parole de l'expérience moédale auprès du LHC et concentre ses efforts sur la recherche de nouvelles physiques à la frontière de la haute énergie et du cosmos, en quête de vestiges du moment où l'univers est né. Alors, avec ces mots, je vous présente le film de M. Pinfold.
Dear all, I would like to apologize for not being able to attend the Killam event on the interdisciplinary importance of rhythm. I had a previous research commitment at the European Centre for Nuclear Research, or CERN for short, so I've made this movie as a stand-in. I hope you enjoy it. Pythagoras was one of the most famous and controversial ancient Greek philosophers. He was born around 570 BCE and lived for most of his life on the island of Samos, a green jewel in the crystal-clear azure Aegean Sea. Pythagoras noticed that vibrating strings produce harmonious notes when the ratios of the lengths of the strings are whole numbers, and that these ratios could be extended to other instruments. He also believed that this understanding could be applied to the planets themselves. All heavenly bodies rang out notes of vibration based on their orbit and distance to each other. To him, the language of the universe was mathematics, the transcendent set of principles that could explain these relationships, and also the structure of the innermost workings of the universe. The voice of Pythagoras, the first theoretical physicist, echoes from the exquisite wreckage of ancient history. He said, "There is geometry in the humming of the strings. There is music in the spacing of the celestial spheres." He was one of the first to reject a universe animated only by the gods, for one comprised, at its most fundamental level, of waves, symmetries and harmonies, sounding together to make universal music. We can follow the faint but luminous thread of Pythagoras' ideas from those ancient times to the first cosmologists, Copernicus and Kepler. It was Kepler's devotion to the idea of geometric beauty that informed his revolutionary book on the motions of the planets, Harmonies of the World, published in 1619. It was Kepler who introduced the modern conception of the harmony of the spheres in the sun-centered solar system. He had come upon his revolutionary planetary laws where orbits were elliptical rather than circular by trying to find a congruence between musical intervals and the motions and distances of the planets. To Kepler, the celestial rhythms of the planets were perceptible only in an abstract sense. They combined to create hidden melodies. Kepler also discovered that the ratio of the orbits of the then 6 known planets were the same as the ratios between a nested Russian doll configuration of the 5 Platonic solids and a cube. Here Kepler established a link between rhythm, harmony, and symmetry. Even the divine Newton relied on the hidden melodies of the universal music to guide his thoughts to create new rhythms and harmonies. He linked the 7 musical notes with the 7 colours of the spectrum of light, the 7 planets known at the time of the solar system, and the 7 notes of the musical scale before the return to the octave, inventing as part of this process the colour indigo to make up that 7. Going further, he credited Pythagoras for his fundamental insight that gravity obeys the inverse square law. He said he, that is Pythagoras, understood by means of the harmony of the spheres that the weights of the planets towards the sun were reciprocally as the squares of their distances from the sun. This was a core of his dazzling theory of universal gravitation, that unified celestial and terrestrial gravity written down in his greatest work, the Principia. In the second part of our film on hidden melodies, we shall show how the rhythms, harmonies and symmetries of the fundamental universe were recognized and understood by modern physics. This new understanding of nature was ushered in largely by the work of Michael Faraday and James Clerk Maxwell, who show that the universe is awash in the music of electromagnetic rhythms played on the vacuum itself, and that light is a mutual embrace of vibrating electric and magnetic fields. Einstein and the core of modern physics followed the inaudible strumming of those same cosmic rhythms. For him, beyond observation and theory, lay the music of the spheres, an archetypal harmony of fundamental symmetries. He showed that even gravity waved throughout the universe, producing hidden songs that have only recently been perceived by contemporary science. In the 1920s, the quantum theorists Bohr, Heisenberg, de Broglie, Schrödinger, and Born transformed our understanding of heretofore mute matter, revealing its song of waves, dancing energy, and its underlying mercurial probabilistic nature. These new harmonies of the microverse revealed by these quantum revolutionaries may have the apparent dissonance of Stockhausen or Glass, rather than sublime pure precision of a Bach or a Mozart of classical physics, but this is because we need new senses to perceive them properly. Today, physicists are hypothesizing new harmonies, new symmetries, and even broken symmetries, sounding much deeper in the microcosm than the atomic world, reaching down to the very roots of the universe itself at the Planck scale. This universal music, expressing a theory of everything, plays in a hyperspatial auditorium of multiple dimensions, more than the 4 we know, where even the fundamental particles or vibrations of the fundamental strings or membranes described by string theory or M theory. I would like to leave this first part of the film with the words of one who held the idea of beauty and harmony central to his being, John Keats. He said, "Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on."
First of all, I just wanted to thank you for making this film, Jim.
You're welcome.
It's quite an accomplishment in such a short time. So I have the questions that I sent you, and just let you answer in whatever way you would like. Do you have a background in the arts or no?
My other passions are physics, beside physics, are painting and sculpture, and I qualified to enter art school when I was before I went to university, and I even took classes at the Royal College of Art, um, which I had to give the classes up, not the practice of art, but I had to give the classes up to concentrate on my physics at the Royal College of Science. Um, but I think my approach to science is rather that from the point of view of an artist, actually, visually, completely agreeing with Einstein's insistence that imagination is more important than knowledge. But of course, knowledge is still important. In my opinion, the artist and the scientists are trying to do the same thing in the broad sense, and that is to reveal, to make visible the invisible. So I think we have common aims, and when you look at the development of art and the arts, they follow a kind of similar path, like dreamwalkers, like sleepwalkers dreaming the same dream. We tend to go through the same revolutions.
At one point in your film, you say these new harmonies of the microverse revealed by these quantum revolutionaries may have the apparent dissonance of Stockhausen or glass rather than sublime pure precision of a Bach or a Mozart to classical physics. But this is because we need new senses to perceive them properly. How would you characterize what you mean by that?
So in the classical world, we're dealing with classical physics. And the physics, classical physics, is valid at scales that human beings are accessible to. For example, distances, speeds, accelerations, and forces, they're on a scale that could be experienced by humans, right? And we're dealing with light, sound, and so on, inputs, physical inputs that could be experienced by human beings. So broadly speaking, the classical world is accessible to our human senses and our human understanding, so to speak. However, the realm of modern physics includes relativity and quantum mechanics, and that takes us to new regimes, speeds near that of light, ultra-high gravitational fields, atomic distances that are microscopic fractions of a centimeter, elementary particles. This realm is bathed in new lights that we can't even see, like ultraviolet light, X-rays, gamma radiation, particle waves, etc. So that whole realm lies beyond the reach of our human senses. So we usually need detectors to mediate between our world and the world of modern physics. These are the new eyes I was talking about, or the new senses, the detectors that we need to build, to understand, to link with these new worlds.
Dr. Ishinsky watched your video, and his question is whether rhythm is an energy saving fundamental.
Well, I think that the rhythms, and I'm going to mention harmonies and symmetries, all almost in the same breath, because rhythms make harmonies, and symmetries are the same thing as harmonies, but visually, in my opinion, anyway. So I think that rhythms, harmonies, and symmetries are a result of the fundamental laws of physics. But also, in the same way, the fundamental laws of physics are the result of the rhythms, harmonies, and symmetries of the universe. So they're two halves of the same coin, so to speak. So the principle of minimum energy that Vladimir is talking about is in essence another way of stating the second law of thermodynamics, which we all know is a fundamental law of physics. So from my statement, the statement I've just made, I maintain that the principle of minimum energy is fundamentally linked with underlying rhythms, melodies, and symmetries of the universe by definition.
Janet Verker,
Yeah.
she says she has a big question for you. Does he think these hidden rhythms also characterize biological systems, both plants and animals?
Chemistry and biology are constructed from the fundamental building blocks. So the fundamental rhythms are there, but combining into, say, complex melodies, and even in the case of biology, symphonies, if we're using the musical analogy. So yes, I think they are there, but much more complex and combined and interleaving and intertwining. I think this could be a great topic for a film of its own.
Do you see the development of your science as being composed of people that have been open-minded enough to gain insight from this other realm to bring it into the sciences over time?
Yes, I believe that rhythm, music, harmony, symmetry have been used as a source of insight by physicists since the very beginning. And the fact this approach has been successful leads me to believe these properties are inherent in the structure of the universe. I think that a lot of I say the best, perhaps I'm being a bit arrogant there, but I think the very best and most hard thinking scientists understand this. I think it's about time we brought them together. Unfortunately, a lot of the aims to bring arts and science together have often been rather contrived. I think rhythm and melody and symmetry give a rather natural way to bring loads of areas of human thought together under one umbrella, where we can understand what we're all trying to do as really one thing.
So I thank you very much for taking this time with me. Thank you very much.
Bye bye.
Bye.